Hello, everyone. Welcome to my final presentation for the compiler design and implementation course. And I just wanted to say that I called my compiler the Dragon compiler after the Dragon book. And despite all the challenges I had in this project, I'm happy to say that I finally was able to compile some programs. So let's get started. So the first part of the compiler was the lexer, and at first it took some time to understand the format of the submissions, reacquaint myself with C, and learn the lex syntax. Comparatively, it was the easiest part of the compiler, but it kind of didn't seem like that at the start. And some extra parts, including reading strings and identifiers of unlimited size using dynamic memory allocations, were added. I also added the fact that it could read like symbols like new lines or tabs. And here's the demonstration of how the lexer works using this program. The second part of the compiler was the parser, and the parser was pretty straightforward after I finished implementing it. And the challenging part was learning YAC and understanding how it actually interacted with lex and how to use it for the abstract syntax tree creation. Because all of these technologies were so new to me, it was hard to comprehend how one led to another. And here is how the parser looks like, the output from the parser looks like. And I tried to make it more prettier with added new lines. The third part and the part of the compiler that I had the most problems with was the symbol table part. And creating the symbol tables was definitely the most challenging. And it took a long time for me to figure out a way to invert the type tree and get a good structure for the tables. At first, I wanted to implement the stack and actually started implementing it, but it led to a lot of problems. And so I had to scrap it and start over with the linked list tables. And in this part, I immediately attached the symbols to the respective identifiers. So it was fairly easy to access them during type checking and IR code generation. So I didn't have to like traverse the symbol tables each time. The only time I had to fully traverse the tables, apart from the time where I had to print them in the third problem set, was in MIPS. And additionally, I added the level of each block scope of the tables, which was useful for the MIPS generation part, since we had to have the same offset for variables that were at the same kind of level of block scope. And here's how the symbol table works. So we have the variable, the type of the variable, and also the table ID, which is unique for each symbol table. And for functions, we have the return type and the type of each parameters of each parameter of the function. The first type was type checking, and it was pretty straightforward with the help of Harbison and Steele, which I referred to a lot during this part, and it was clear on the C89 rules and standards. And in this part, I learned so much about C and how to correctly write it. And during this part, I also encountered a lot of memory management and allocation errors here, and I had to return to this problem set multiple times during the IR stage and the MIP stage because I kept finding some mistakes and occasionally a psych fault for a program. And here's a demonstration of how the type works. Okay, I'll show the parser type first to really show what it does. So as you can see here, it prints all the original types in the parser, and then during type checking, it adds the casts. So since I is assigned short int and we're multiplying with an int, we are adding the signed int cast here, but then converting it back to assigned short int since we're assigning it back to I. And here, since syscall print int takes an int as its parameter, we're adding a cast for I and converting it into an int. And one of the other things that I wanted to show is these increments and decrements, and to show how it works. And so the casts here are in a comment since we are unable to actually add casts onto the left-hand side of the separation since it needs to be an L value. So the fifth part was the IR code generation, and it was actually one of my favorite parts of the compiler building process. I found it very interesting and not that challenging to understand once I got to it. And I used the structure from the sample compiler for this part, and I just wanted to mention that I used the sample compiler a lot, and I probably wouldn't have gotten this far without it. And the only challenging part was the amount of the scenarios I had to account for when generating code. And one of the additional features sort of was adding the phi instruction to maintain the single assignment for registers. And here's a demonstration of how the IR works. And so this is all of the IR code. The final part was the mixed code generation, and it was a bit challenging to comprehend at first since it's like such a different language and I never had any experience, neither with assembly or any other kind of machine code language, but it got easier after I started the implementation. And once again, I had some errors pop up from type checking and IR code generation and had to find a way to attach the block scope tables because they were sort of like dangling there in my symbol tables, and I had to determine the levels for them to calculate the stack offsets. And one additional feature here was that I added the syscall functions into the symbol table, which allowed the compiler to use them without declaring them at the start. And here's a demonstration of how MIPS works. And I can actually compile this code using SPIM. And the result is 2, which we clearly have here. So we're inputting 1 in this function, and this one is just returning a double of this function. And this prints 2. So some of the other programs that my compiler can compile is arrays. So here, where I'm declaring an array of size 5 and then assigning the 5 numbers here and printing them in order. So as you can see here. And I'm also able to compile the factorial program from the class example. So factorial of 6 gives us 720. So for the optimizations part, I attempted to do the loop unrolling and the graph coloring based register allocations, and I started learning about them, but unfortunately, I didn't have enough time since I had to solve some bugs related to problem set 6. But I manually tried the loop unrolling optimization for a for loop, and it actually reduced the time by 25%. So I tried a loop that prints numbers for a really large value, and without the loop unrolling, I got it like the function ran for 49 seconds, about like 50 seconds, but with it ran for approximately 35 seconds. And for this part, I also added additional test cases for my compiler. So thank you so much. I really enjoyed this course and I felt like I learned a lot. And I'm happy that I didn't give up with my compiler and was able to compile the programs, which was really exciting the first time it happened. So thank you.